Hello students, welcome to the next lecture. This lecture is the last lecture for non-concurrent forces, coplanar forces. Means the ongoing chapter is completed in this lecture. Today we will discuss some theories, some small theories, one or two numericals based on this, and that's it for the chapter. Let us see the topic of the lecture today. Position of the resultant force by moments. Actually, we have discussed about the moments. What is moment? It is equal to force into perpendicular distance. But now, with the help of this moments, if you remember the Varignon's principle. Okay, so according to Varignon's principle, algebraic sum of all the moments about certain point is equal to the moment of the resultant about the same point. So with the help of this moment, we are trying to locate the direction and position of the resultant now onwards for the coplanar non-concurrent forces. Let us see how. Here the steps are written in the box. You can read. It is also known as analytical method for the resultant force. The position of the resultant force may be found out by moments as discussed below. There are two steps actually. Step number 1. First of all, find out the magnitude and direction of the resultant force by the method of resolution as discussed in the chapter composition and resolution of forces, means our first chapter in the phase number 1. Now the second step is now equate the moment of the resultant force with the algebraic sum of moments of the given system of forces about any point, means apply Varignon's principle. It is not so easy. You just see numericals after one or two theories, then after you can realize how the moments can be applicable. This may also be found out by equating the sum of clockwise movements and that of the anti-clockwise movements about the point through which the resultant force will pass. Let us see how all the things are applicable. Let us go ahead. See the example over here. So in this example, the system consists of three forces on an equilateral triangular plate. You can see it is 2p, 3p and 4p. The length of each and every side of the triangle is 100 mm. You can see the angle inside the equilateral triangle is 60 degree. 60 degree for all the three angles because it is an equilateral triangle. Let us see the data first. Three forces 2p, 3p and 4p acting along the three sides of an equilateral triangle of side 100 mm taken in order. Find the magnitude and position of the resultant force. Means we have to find resultant force, magnitude and positions. Magnitude means value and position means in this figure actually from which direction the resultant will be passing. That is known as position of the resultant, which we have to find. Let us see first of all magnitude of the resultant force. Resolving all the forces horizontally means in this figure horizontal force is only 2p. But this 3p and 4p are inclined forces, so we have to make horizontal components of 3p and 4p. So sigma is equal to 2p first. Why it is positive? Because 2p is going towards right side. So right side means positive x-axis, so it is positive value. Plus 3p cos 120. You can see this is 3p. If you make the components of 3p, the horizontal component will be like this. Okay, will be like this. And this angle will be 60. How it is 60? You just have to calculate it. Okay, this angle is 60 and the value is 3p cos 120. Here it is, this component will be 3p cos 120. But if you want to take it positive, then it will become 3p cos 120 on the opposite side. The angle will become 120 in this direction. So 3p cos 120. And similarly for the 4p, the horizontal component will go in the left direction at an angle 60 degree over here. But if you want to take it positive, then it is 4p cos 240. Or simply, this is the complicated method, or you can directly take it. Here it is negative 3p cos 60 actually, and here it is negative 4p cos 60 actually. Then you will get your answers. Okay, here the angles are taken from the positive x-axis only. So now final answer of sigma h will be like this. You can get it from the simplification in your calculator. So final answer is 1.5p and given it is as equation number 1. Now resolving all the components vertically, then what happens? Vertical component is only for this 3p and this 4p. Vertical component of 4p is going down and vertical component is 3p is going up. So it will be 3p sin 60 positive and negative will be 4p sine 60 as written over here. You can see here it is negative sign. They are not trying to make it positive at any cost, at any angles. So with the help of this, in your simplification of your calculator, you will get the answer of 0.866p in the negative. So this is the equation number 2. So these are the sigma h and sigma v for the given force system. Now let us check what happens with the resistance. You can see our formula of the resistance is under root of sigma h square plus sigma v square. This is sigma h, this is sigma v. By simplification, you will get the answer 1.732p in the form of p. Now, this is the resultant. Actually, we are not having the value of p. If in your numerical, in your exam, if p equal to 60, then the given forces are 120, 180, 240, etc. Then you will find the resultant with the help of these values. Okay, so this is the master sum or standard sum. Now, what happens with the position of the resistance? Let x equal to perpendicular distance between B, remember this, between B and the line of action of the resultant force. So we are trying to find the resultant force with the reference of point B only. Now, taking moments of the resultant force about B and equating the same. So what is actually the resultant? The resultant is 1.732p. So according to Varignin's principle, moment of resultant force is equal to moment of sum of moment of all another forces. Okay, so what you have to do, always take left side of the equation as resultant into x. Where is x? X is not visible in the picture, but actually x is the distance of resultant and point B as in this figure. Repeating again, x is the perpendicular distance between the resultant force and point B. Wherever it is from the upper side of point B, it is from the lower side of point B, it is from the right side of point B, it is from the left side of point B, we doesn't know it. Okay, just take it arbitrarily r into x. So here it is r 1.732p into x. Now remaining forces. Now taking moment about point B, this 4p is passing from point B. So resultant of moment of this force 4p is cancelled out because it is passing from point B only. So distance will be 0. This force 2p is also extending and passing from point B. So perpendicular distance of this force 2p from point B is 0. So moment of force 2p is also cancelled out. So only one force is remaining, that is 3p. So 3p into 100 sine 60 is the perpendicular distance. Actually what happens? 100 is the perpendicular distance and the horizontal component means the component in the vertical direction, it is 3p 100 sine 60. So sorry, 3p sine 60. So the distance will be 3p into 100 sine 60. By replacing the values, you will get the answer of 259.8p. So now by solving, p will be cancelled out from left and right and you will get the answer of x as 150 mm. It means what? The resultant is passing at a distance of 150 mm from point B. So this is known as resultant position of the resultant. Actually we don't know where is the resultant in the figure, but we arbitrarily find that the resultant will be at a distance of 150 mm from point B only. Okay, this is the example for the triangle. If you are not getting clear about this triangular figure, then let us check one another example which is based on the square. See this example. In the same type of method, in the square, there are 4 forces now. P, 2p, 3p and 4p. 4 forces respectively acting along the 4 sides of square ABCD taken in order. And we have to find the same magnitude, direction and position of the resultant. Here we have to find the direction also. Means the angle also for the resultant force. Let us see how. Resolving the forces horizontally and vertically, first of all find sigma h, sigma v and then after the resultant. You can see in this figure, which are the horizontal forces. First one is P, which is positive going right. Second one is 3P, which is negative because going left. So answer is P minus 3P. It will be minus 2P, equation number 1. Only 2 horizontal forces are present. Vertical forces. Which are vertical forces? They are 2P and 4P. 2P is going up, means positive axis positive. 4P is going down, means negative axis negative. So answer is 2P minus 4P will be minus 2P. So answer equation number 2. Equation 1 and 2 having same values, minus 2P and minus 2P. So finding the resultant as under root of sigma h square plus sigma v square, we will get minus 2p square plus minus 2p square. Answer is 2 root 2p is the resultant of our force system. So hope this is very clear to you rather than the triangle. Okay, for the triangle you have to understand the geometry very well, the angles very well, and the components very well. Let us see what happens with the direction and position of the resultant. For the direction, we know the formula of theta. What is theta actually? In the first chapter, tan theta is equal to mode of sigma v upon sigma h. Sigma v and sigma h having same values, so answer is 1. So theta is equal to 45 degree. So this is the resultant 45 degree, but sigma h as well as sigma v are negative. Therefore, the resultant lies between 180 and 270. Both the values are negative. Sigma h negative, sigma v negative. So answer will be lying in the third quadrant. Okay, answer is lying in the third quadrant. So the theta will be lying from 180 to 270 degree. Obviously. So this will be calculated like this. 180 plus our answer 45 is equal to 225. So 225 is the value of direction of the force which is lying between 180 and 270. So this is the answer of position of the resultant. Let us see, direction of the resultant. Let us see what happens with the position of the resultant. Means we have to find x now. Okay, so here let us see x is the perpendicular distance between A and the line of action of the resultant force. Here the reference point is A only. Where is A? Here you can see this is point A. So we are calculating x with the Varignon's principle. Now what is Varignon's principle? Resultant's movement about point A is equal to sum of all other movements about point A, same point. Okay, so what we have to do? Resultant into x, replace on the left side arbitrarily. So resultant is 2 root 2p into x. What are the other forces? Take the moment of this forces about point A. So while taking the moments at point A, 4p will be cancelled out because it is passing from point A. P is also cancelled out because it is also passing from point A, you can see. So remaining forces are 3p. Now 3p is moving like this. You can see like this. So it is anti-clockwise. And the force 3p is horizontal. So perpendicular distance will be this. So 3p into A, which is anti-clockwise. And the other force is 2p. This is the vertical force 2p. By extending, this is 2p. The perpendicular distance is also the side of the square, means A. It is also rotating like this anti-clockwise. Okay, about point A. So the answer will be 2p into A. So this both the movements 2p into A and 3p into A both are anti-clockwise. Okay, so you can see both the values are taken as positive. If the answer is clockwise for both the movements, then also it is positive. If the answer is anti-clockwise for both the movements, then also it is positive. Doesn't matter. But if one force is anti-clockwise and the other force is clockwise, then one value should be taken as positive and the other value should be taken as negative, but such that the total answer will be positive only. So make sure that the bigger value should be taken as positive and the smaller value should be taken as negative. Okay, so the final answer will be 5p into A, and by solving you can get x equal to 5a upon 2 root 2. Actually A means the side of the square which is not available to you, so this is the master sum. If you replace the square side as 5 meter, then you will get the answer in your calculator, x equal to 5 into 5 upon 2 root 2, something like that. It is in meter or mm or centimeter as per the given figure in your data. Okay, so by this method you can find the resultant, which is the magnitude of resultant. Then after, direction of the resultant means angle theta, depending on the quadrant as per our chapter number 1. Then after you can find the position of the resultant, which is x, with the help of Varignon's principle. So these are the numericals frequently asked in your JDU exam to find the magnitude, direction and position of the resultant force. Lots of cases are available which you can verify from your question bank, and you can ask me for any doubts. Let us see the further topics. The one and only one smaller topic is now left in the chapter, that is couple. Let us see couple, types of couple and characteristics of couple. Then after this lecture will be concluded, this chapter is also concluded. What is couple? You must know about the lock and key system. If you rotate the key in the lock, then a couple is a pair of forces applied to the key of lock. When you open the lock, it is a clockwise couple. When you close the lock, it is anti-clockwise couple. Like that. You can read in the box that a pair of two equal and unlike parallel forces, means forces equal in magnitude with line of action parallel to each other and acting in opposite direction is known as couple. So this is the definition of couple only. As a matter of fact, a couple is unable to produce any translatory motion, means by rotating the lock and key is not going anywhere. They are same at the position. Motion is a straight line, motion in a straight line, but it produces a motion of a rotation in the body on which it acts. The simplest example of a couple is the forces applied to the key of a lock while the locking or unlocking it. So locking or unlocking means the equal and opposite, anti-clockwise and clockwise movements are applicable. That movements are known as couple. Okay, let us go ahead and discuss it in detail. So what is arm of couple? You can see this is a rod. At the ends of rods, the forces are equal, opposite and parallel acting. You can see this is the force P, then this is also force P. Both are parallel to each other but in the opposite direction, having same values P. And the distance between these two forces is small a, you can see. Then the arm of the couple is the length between two equal and opposite parallel forces. Means between the lines of the action of the two equal and parallel forces, the perpendicular distance A is known as arm of a couple. So this value A is known as arm of a couple. What is moment of a couple? The moment of a couple is equal to P into A, means the magnitude of two equal and opposite forces multiplied by distance between these two parallel forces. Means P is the value of the force and distance between the forces is A, means arm of a couple. So product of value of the force and arm of a couple is known as moment of a couple. So P is equal to magnitude of the force and arm means A. So this is known as moment of a couple. Now there are two types of couples are there. Clockwise couple and anti-clockwise couple. Let us see clockwise couple first. A couple whose tendency is to rotate the body on which it acts in a clockwise direction is known as clockwise couple as shown in the figure. Such couple is also known as positive couple. You can see the same rod, same figure, two equal and opposite forces P. The arm of a couple is A. But by applying these two type of forces, the arm or the rod is rotating like this, automobile steering. So it is a clockwise couple. Now what is anti-clockwise couple then? You can see the opposite figure. Here at point B, the forces is in the upward direction and at the point A, the force will be in the downward direction. So it will try to rotate the rod in the anti-clockwise direction. Okay, so that's why it is known as anti-clockwise couple. You can see the motion or the movement of your automobile steering, your car's steering, clockwise steering, anti-clockwise steering. So this type of couples are known as clockwise and anti-clockwise couple, which try to rotate the body in the clockwise or anti-clockwise direction respectively. Let us see some characteristics of couple. This is our last topic of the chapter. What is characteristics? There are mainly four characteristics, means properties of couple. The algebraic sum of the forces constituting the couple is 0. Means on the body, the net total of the forces will be 0. Means upward forces is equal to downward forces. Net effect is 0. So body is just rotating, not moving anywhere in the translatory direction. Okay. Number 2, the algebraic sum of the moments of the forces constituting the couple about any point is the same and equal to the moment of the couple itself. So moment of the algebraic sum is equal to moment of the couple. A couple cannot be balanced by a single force, but it can be balanced by only a couple of opposite sets. Means if there is a couple in the clockwise direction and you have to balance it, then equal and opposite couple means two parallel forces are applied in the opposite direction, means in the anti-clockwise direction. Not a single force can balance the couple itself. Okay. Now number 4, any number of coplanar couples can be reduced to single couple whose magnitude will be equal to the algebraic sum of the moments of all the couples. So you have to just remember these properties, or you can say the characteristics of these couples. This is only important for the exam point of view, nothing else. So these are the characteristics of a couple. So this is the conclusion of our chapter. It is very small chapter. Only one type of numerical is asked in the exam, that is the magnitude, direction and position of the resultant. Theories are very small. One is Varignon's principle and the second one is movement and couples. Okay, types of couples, characteristics of couples and the definition of movements. You have seen the one numerical for based on movements also, based on position, direction and magnitude of the resultant also. So just revise this numericals, just revise this theories, which is conclusion of the chapter. So this is the chapter coplanar non-concurrent forces. In the next lecture, we will start another chapter, that is torsion. So till then, thank you very much students. Revise the lectures again and goodbye.